So in this video I'll be showing you how to segment white matter using ITK Gray. But before we get started, we'll just go through some shortcuts. Alright, so the first shortcut we'll be going through is, I guess, the S key, which is show hide. So you can either show or hide whatever you've filled in already, and that's quite helpful for determining whether or not you're coloring gray matter or white matter. The next shortcut is the A and D keys. So A is decrease and D is increase opacity, and that's also quite helpful if you need to delineate grey and white matter. The next shortcut are the toolbox keys. So the keys 1, 2, 3, 4, 5, and 6. You'll pretty much only be using 2 and 5, which are zoom and paint. So you don't really need to worry about using the other keys. And lastly, the next shortcut I can recommend is Control S, which is saving. So throughout your whole segmentation, it's very important that you save regularly, because it takes, I guess, hours and hours to color in white matter, and the last thing you want is it to crash and you haven't saved it. Alright, so to summarize, we have the S key, which is to show and hide what you filled in. You have the A and D keys, which are decrease and increase opacity. You have all the toolbox options, 1, 2, 3, 4, 5, 6, and also save, which is Control S. So I've also listed a summary of what each toolbox option exists. So as I said earlier, we'll only be using the zoom tool as well as the paintbrush tool. We'll also be using the crosshairs tool seldomly, but not really. So just focus on the zoom tool and the paintbrush tool for this tutorial. So before we get started, I've listed all the steps needed to segment a brain using ITK Gray. I won't go through each step just this minute, but I will list them at the end of the video, but feel free to pause here if you want to read them all now. Okay, so getting started on the tutorial. So the first thing you want to do is open up your anatomical file. So firstly you go to File, Open, Browse, and then you go to the location where your file is. And then after that, just keep on pressing Next, and I guess make sure all of the parameters are correct. But then you should have loaded up your anatomy, and you can see it here in the 3 windows. Across 3 different views. So you've got axial, sagittal, and coronal. Alright, so the next thing you want to do is adjust the contrast of your T1 image so that it's easier to delineate the white and grey matter. So to do that, you go to Options, Adjust Image Contrast. And then you should see a window pop up showing you the amount of luminance values, but you can just press Auto and it should do a pretty good job for you. And so that's how you adjust the image contrast to make it a bit easier for you to segment. Alright, so the next thing you have to do is create a segmentation file. So to do this, you go to File, Save, Segmentation Image, and then after that you have to name your file. So usually I just do an underscore seg, or you can just name it segmentation, whatever you want, and then just press save. And then after that you have created your segmentation image. So now that you've made your segmentation image, you're pretty much ready to start segmenting. So typically we start segmenting the left hemisphere, but you can start on the right if you wish. But essentially the way that I do it is that I first go through each view, so axial, then sagittal, then coronal. So I go through all the slices within each view and just flood fill it. So you have to go to the paintbrush option in the little toolbox window. So you can press the 5 key to use a shortcut, and then what you can do is increase the size of your paintbrush, decrease it, and you can also change the tolerance. So by increasing the tolerance, you're basically allowing the program to fill in more white matter or have a less conservative, I guess as to what white matter or grey matter is. And then you can decrease the tolerance to make it more conservative. Typically I don't change the smooth option, but you're more than welcome to. But usually I start with a pretty high tolerance and just flood fill what I see as white matter and just go through all the slices. It's also important to keep the 3D brush checked for when you're doing, I guess, the initial iteration of segmenting. This is so it paints in 3D, so it typically makes it a lot faster. But when you want to paint in things with more detail, you can uncheck this, or if you're filling in ventricles, it's also important to uncheck this option and just do it slice by slice. So another way of starting the segmentation process is by just filling in the ventricles and creating a border between left and right hemispheres. I won't do that for the left hemisphere segmentation, but I'll show you how I do this for the right hemisphere. So if you want to see this before starting your segmentation, just fast forward the video to the right hemisphere and I'll show you how. Okay, so we can start segmenting the left hemisphere. So typically I start with the first slice on axial view, and typically the image becomes smaller when you go to the top of the head, so you can use the zoom function in the toolbox, and that's number 2 on the keyboard if you want to use the shortcut. And you can use the zoom function to make the image bigger, so you can do this by holding the right click button on the mouse and dragging the mouse either towards or away from you to make the image bigger or smaller. Once you've got the right image size, now you can go back to the paintbrush tool by pressing the 5 key on the keyboard. And once you've got your brush size and tolerance sorted, you can start segmenting. So to fill in white matter, what you have to do is use your mouse, and once you've found an area of white matter, you just click on it using the left click button, and by doing this the computer estimates how much of that is white matter or grey matter, and if it happens to overestimate this, you can go to the part that's overestimated and press the right click button on the mouse to erase it. And so basically you'll be doing this over and over again across all the slices in the 3 different views, filling in all the white matter. Also, I forgot to mention that if the tolerance is too high, it will overestimate the white matter, but what you can also do is have a high tolerance and fill in all the white matter, and then decrease the tolerance to erase whatever is overestimated. It really depends on your style of segmenting as to how you do it. You may also be concerned that if you're segmenting the left hemisphere, some of the right hemisphere will be filled in as well, but for the time being, don't worry about that. We'll erase that at the end of the first iteration through all of the slices. So as you fill in the slices, as you go down, you'll notice ventricles, and it's up to you whether or not you want to fill them in as you go along. What I've done here is used a different shape brush, the round brush, and I've also checked 3D brush, but what I actually recommend you do is not use 3D brush and actually go through each slice manually and fill in the ventricles. The reason for this is because when you fill in things other than white matter, things tend to get a bit messy when you use 3D brush. I just tried it out here, but I'll show you in further detail how to do it when I segment the right hemisphere. So if you want to look at that, just fast forward. So once you've gone through all of the slices axially and you've, to the best of your ability, filled in all the white matter, things may look a bit messy around the brainstem and also where the ventricles are, but that's okay. So once you've filled in all the main bits, just go through and do a double check and just fill in what you haven't filled in. But the next step is to clean up all of the white matter that's overextending to the right hemisphere, or if you haven't filled in the ventricles yet. So the easiest way of cleaning up all the extended white matter on the right hemisphere is to go to the paintbrush tool and change the shape of your paintbrush to square and make the size really large, so maybe 200 or something like that, and turn off 3D brush and just go through and make, I guess, a nice border between the left and right hemisphere, and just leave the brush in that same position and just erase. So press the right click key and just go through each slice and erase as I'm showing you here. And so this should make a very nice border between the two hemispheres that you should see on a 3D mesh of the brain, and I'll show you that later. But yeah, just go through all the slices and do this. It's a bit meticulous, but it's pretty easy to do. So while you're creating this nice border between the left and right hemisphere, you may also notice some areas of white matter that you didn't color in or are overextended, so you can also clean this up during that time. So once you've finished cleaning up all of the white matter that got extended to the right hemisphere, and you've also filled in all the ventricles and cleaned that part up, you can view what you've filled in on a 3D mesh. So to do that, what you have to do is go to the segmentation options toolbar on the left hand side of the window. Make sure that the active drawing label is set to left white, and then press update mesh, which is on the lower left hand window. So as you can see, now you've got a 3D model of what you just filled in of the left hemisphere, and as you can see, it's pretty rough at the moment. So the next step is to smoothen your initial iteration out. So what you have to do now is go to the topology option in the toolbox and then press smooth twice. So as you can see, after smoothing the segmentation, it looks a lot nicer than it did before. So while the segmentation does look a lot nicer than it did before, sometimes smoothing undoes some of the segmentation you did. So if you colored in some white matter after smoothing, some of it may be erased. So just be aware of that, because the more you smooth, the more it erases. Okay, so you've just completed a very rough iteration of a left hemisphere segmentation. So it's not completed just yet. So considering that I'm in a vision lab, what we're most focused on is the back of the head, so the occipital lobe. So what I'm going to do now is actually go through each view, so starting with coronal, then going to sagittal, then going to axial. So I'll go through each slice, just covering the back of the head, not the whole brain, so maybe about 50 slices in coronally, and going through meticulously to make sure all of the white matter is labelled. So to do this, I typically set the tolerance to a value very low, so something around 7, or sometimes I even use 5, and I also use a smaller size than usual. So here I'm using around 20. However, when there's a spot where the delineation is quite close, I'll use a smaller size, so maybe 5. So this bit's a bit boring, but essentially you just have to go through all the slices that contain visual cortex and meticulously go through and erase anything that's been overestimated to be white matter, and fill in anything that hasn't been filled in yet. And so you just got to do this across the 3 views. And yeah, it will take you a little while, but just make it as neat as possible. So once you've finished going through each of the three views, coronal, sagittal, axial, and all the slices which contain visual cortex, you can go update the mesh and see how smooth visual cortex is in terms of the segmentation. And the next step is to either smooth it if you think it's not smooth enough, or start looking for handles. So you're probably wondering what a handle is. So in terms of the ITK Gray software, a handle is a hole in 3D space. So if there's paint filled in for the left hemisphere that doesn't seem to connect in 3D space, this is what's called a handle. And so at the end of your segmentation, you have to get rid of all these handles. So in order to get rid of the handles, you have to use the topology check function, which is the same as the toolbox used to smooth your segmentation. So as you can see here, I've smoothed the segmentation one more time, and I did this because I thought it was looking a bit messy. But essentially, what you have to do to look for handles is press the update key in the topology toolbox, and as you can see here, there's a number and it says I have 6 handles, so I have to go through and look for these handles and fill them in. But firstly, if the topology check says that you have any cavities, make sure to fill them in by pressing the fill key, and then after that, to actually look for the handles, you have to press the find button. And depending on your computer processing speed, this may take a while, but if you have a small number of handles, it shouldn't take too long. So once it's finally found them all, what it actually does is it provides coordinates for where these handles are. So you can see there is a little drop-down menu bar here listing the coordinates, and you can press the drop-down menu button and it will list them all. So another thing you have to do before filling in handles is uncheck the cursor chases brush option, which is in the paintbrush toolbox. So the reason you want to uncheck this is because handles are determined by specific coordinates, which are shown in the 3 windows here, as indicated by the blue crosshairs. So if the cursor chases brush option is checked, then the blue crosshairs will move every time you move the brush to fill in or erase something. So if you have this option unchecked, then whenever you fill in something, or if you scroll through the windows, this blue crosshair will stay in the same position, indicating where your handle is. So it can actually be pretty tricky finding where these handles are. The coordinates aren't exactly where the handle is sometimes, so you'll have to go through the slices in all of the views to sort of figure out where it is. But sometimes it's obvious, like in this instance where I've got a gap between the top position here and the bottom position, so all you have to do is go through the slices and fill in this gap, and once you think you've filled it in sufficiently, you can go to the topology option menu again and press the update button, and if you see the handle number go down, that means you've fixed that handle or filled it in. So I've just shown you how to fix a handle. So as you can see, there's 7 more left. So what you have to do is go to the next handle by going to the drop down menu and changing the coordinate and then filling in the gap. So I'm just quickly showing you some examples of handles that are present in this segmentation. I won't go into too much detail as to how I filled them in. It's essentially the same as the example I showed you, where you'll see a gap and you just have to fill it in using the paintbrush tool. So the reason I'm not showing you in too much detail how to fix these handles is because these handles are unique to this particular segmentation. So if you were to do your own, the handles I fix here won't necessarily apply to the handles in your segmentation. However, the idea should be the same, whereby you're just filling in a gap or getting rid of some extraneous parts. So I'll show you a few more examples here without any voiceover, but feel free to skip ahead if you already have the general idea of how to fix handles. Alrighty, so in the video you can see that I've just finished fixing all the handles. So the next step is to check the 3D mesh to see how good of a job you've done, and to also check if there are any handles or any extraneous parts of the brain that have been filled in that the topology check didn't pick up. So as you can see here, there's a hole in the bottom part of the brain, and you can fix this the same way as any handle. But to get the location of this hole, what you have to do is use the crosshair tool from the 3D toolbox and click the location of the hole in the 3D mesh. So this will give you a ballpark estimate of where this hole is. So to actually get it to the exact location of the hole, you have to scroll through using the 3 views to get the crosshair in the middle of the hole. So as you can see, it was actually caused by an extraneous part being filled in. So I've erased this part, and now you'll see that there's another hole that we have to fix. Sometimes that happens when you erase something trying to fix another thing, then that stuffs up something else. So you'll just have to find the coordinates of this particular location and then fill it in. So now that you've filled it in, the next thing you should do is look around the 3D mesh a bit further and see if there are any extra holes or anything that looks funny and try to fix that. But otherwise, for this particular segmentation, I think we're done. So you can go ahead and save it just to make sure it's saved. And as you can see, going through the back of the head, visual cortex, the segmentation looks pretty reasonable, so we can go ahead and start the right hemisphere. So as mentioned previously, I'll be showing you a different way of starting a segmentation. So in this new way, you'll first make the border between right and left hemispheres, and while you're doing this, you'll also fill in the ventricles, so you don't have to worry about filling them in later. Okay, so typically I start in the middle of the brain axially. So just like the way I showed you in the left hemisphere, to make the border between left and right hemispheres, first you turn off 3D brush and you use a large size brush to create the border, and you should use the square shape brush for this. You should also make sure the active drawing label is set to right white instead of left white, since we're working on the right hemisphere now. That's pretty much all there is to it. I generally prefer doing it this way because I don't like filling in the ventricles as I go along. I like to get it out of the way. So to give you a better example of how exactly I do this, I'll play some video without any audio showing you how I make the border between left and right for the right hemisphere. So after creating the border between left and right hemispheres, you segment the rest of the brain the same way as I did for the left hemisphere. So fill in using the flood fill brush and the 3D brush in axial view. And then after you finish doing that, smooth it once or twice, and then fix up the back of the head across all 3 views. So axial, coronal, and sagittal. So after you've done that, if you want, you can smooth it. Otherwise, start fixing up the handles. So after you've fixed all the handles, you should check the 3D mesh for any handles or extra bits of cortex that have been filled in. And if there's any to fix, fix them now. And then after that, double check your segmentation at the back of the head. And if everything looks fine, you've finished segmenting the right hemisphere. So as an extra tip, if you want to only look at the right hemisphere in the 3D mesh without the left hemisphere, go to the Edit Labels option in the Segmentation Options toolbox, and there should be an option to hide a particular label in 3D view. So in this instance, hide the left white label. So this video has shown you how to segment the left and right hemisphere of a brain using ITK Gray. Here's a summary of all the steps you need to take to segment a brain. Hopefully you found this video useful.